Good afternoon, students. This is Secondary Math 1 and Secondary Math 1 Honors, both A1 and B2 periods. Today we're going to talk a little bit about what criteria is needed in order to prove two triangles are congruent. In other words, the exact same size, shape. The first congruency, we call them congruency postulates, is the Sideangleside postulate. For instance, let's look at these two triangles. Let's say we know that one side is 4 units in length on both of the triangles. Another side is 6 units in length on both of the triangles. And the angle that is formed by those two sides is 33 degrees. So as you notice, both sides of the 4 units, 6 units forms that angle of 33 degrees. That's enough information to know the two triangles are congruent, even if we don't know the third side or those two other angles. And we can know that through some simple transformations. In other words, if we do a slide over with the one triangle, line up the vertice, and we do a rotation, we can rotate that triangle back onto the other one and it matches up just perfectly. And we can see that the two triangles are congruent. Now, one thing we need to also be able to do is once we have shown they're congruent, we need to be able to I'm trying to move that one over. There we go. Show that in a algebraic way that those two triangles are congruent. And we do that through this expression down here at the bottom, where we have a little triangle, and then we have the vertices E, H, and F, and then this congruent symbol to triangle A, D, and B. The important thing is that E corresponds to A. This angle E is the same as angle A. H is the same as angle D, and F up at the top is the same as angle B. So we don't want to mix the order up. They need to be in the same order. So when I assign some of my Excel lessons, you need to remember to do that. Again, this is the first one. And remember, it takes two sides and the angle that's formed in between them. That's why the A is in between the two S's, side, angle, side. That's one of the congruency postulates that you need to know. The next one is the side-side-side postulate. Again, if we have two triangles where we know all three sides, and they happen to be correspondingly congruent, so 3 corresponds to this 3 units in length, 5 is congruent to 5, 7 is congruent to 7, we could do a series of transformations where we can slide, do some rotations, and now this one, you'll have to imagine in your mind doing a reflection across that line. If I reflect it, it looks like a kite, or it has symmetry about that line. So I could reflect angle J here over to angle E. And those two triangles would lie on top of each other. So again, we would need to make sure that when we say they are congruent, we do the correct vertices with the other correct vertice that it's congruent to. So F corresponds to A. So on here, A corresponds to F, B at the top correspond to angle G, and J corresponds to E. So we'd say triangle ABE is congruent to triangle FGJ through the side-side-side postulate, where all three sides have congruencies. The next one that we're going to look at is one that can be expressed in a variety of different ways. It's either the angle-angle side, the angle-angle-angle side, or the angle-side-angle congruency postulate. And what I'm referring to here is, first of all, if we have two angles, if we know two angles, like one angle is 33 degrees, one angle is 70 degrees, we actually technically know the third angle as well, because all three angles add up to 180. So in knowing two angles, we actually know three angles. Now, if we have two triangles where we have two of the angles that correspond that are congruent, a 33 with a 33 degree angle, a 70 with a 70, and the side that is in between those two angles, right? We can know the two triangles are congruent by angle, side, angle. And now, if you were happen to given these two angles, not the side in between the two angles, remember, if you know the 2, you actually know 3, and so you can put the S anywhere you want. You could plop the S in the middle, you can plop it on the end. It's all basically the same congruency postulate. But sometimes they'll say angle, side, angle. Sometimes they'll say angle, 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 side. And once in a while, they'll do angle, angle, side. But again, what I can do is I can put one vertice right here on that. Actually, it looks like I need to do this one here. And then I need to rotate this around. And if you'll notice, those two triangles line right up, and we have two congruent triangles through a series of translations and rotations. And again, angle A corresponded to, whoops, I wanted to keep that in the same orientation. Angle A corresponded to D, A corresponds to D, C corresponds to F, and B corresponds to E. So triangle ACB is congruent to DFE. Those are all the congruency postulates we're going to go over today. There is one that students will mistakenly use that is not a congruency postulate, and that's this one. It is the side-side angle postulate. And I put a big circle with a slash through it, meaning it's not a postulate. For instance, if I have a side length of 5, a side length of 6, and I don't know this angle, I can change it any way I want, but this second angle here is 44 degrees. It's fixed. I can't move this side. It won't move. It has to stay at a 44-degree angle with respect to this side 6. I could technically form two triangles. I could come down like this and form a larger triangle where the side length of 5 intersects this opposite side here, or I could bring it around and form a smaller triangle and intersect there. If you'll notice, I haven't changed the length of this side being 5 units. This side length is 6 units, and this angle is 44 degrees, and it didn't even need a change in order for me to bring that side around and touch there. So that is not a congruency postulate. So what's going to happen if you get two triangles where you're given a side, then another side, and then an angle that's not in between the two sides? That's the important part. The angle's not in between the two sides or formed by the two sides. It is not a congruency postulate. So your homework for today or for the next few days is I want you to do in the geometry section in iExcel. So you're going to do iExcel geometry. Down here under K, I want you to do 1, 3, and 5. And if you have any questions on doing either 1, 3, or 5, you can talk to me through Zoom.